Okay, let's begin. All right, hello everyone. Assalamu alaikum. Let's begin. So, in the last session, we talked about how to solve. In the last couple of sessions, we talked about how to solve quadratic equations using factorization, and then using quadratic formula. And then we also discussed what the solutions that you get from a quadratic equation, what they represent. So on a graph, they represent the x-intercepts of this function that you have on the left side of the equation. They represent the x-intercepts of that graph. We talked about how the graphs of quadratic functions look like. They can be U-shaped graphs, they can be N-shaped graphs. That means inverted U. You can call them smiley face and sad face as well. The first one being U-shaped and the second one being N-shaped. How do you figure out which one of these two shapes it's going to be? This coefficient of x squared is what decides that. If the coefficient of x squared is positive, you get a U shape. If the coefficient of x squared is negative, you get an inverted U shape or an N shape like this. Both of these graphs are symmetric and they have this turning point, and we talked about how to find the turning point of this function. The first method for that was using this formula called formula x equals minus b over 2a. That was one formula that we used for this. That gives you the x coordinate of the turning point. And then to find the corresponding y coordinate, you could just put this value of x back in the function, and you would get the corresponding y coordinate as well. For instance, we did this example. We found the x coordinate to be negative 1.5. We put that back in the function to get the corresponding y coordinate in the turning point, and that to be this. Okay, that's what we discussed. And then we talked about the completed square form. So this was the method that we did for that. This was one method that we did. That if you had a function like this and you had to convert that to completed square form, the standard form looks like this. One way to do that would be that you find the turning point first of all using minus b over 2a method. You find, for instance, x equals 2 from this and y equals minus 23 from this. And that tells you that this is the value of h and this is the value of k, right? And then in the standard form, you just input h equal to 2 and k equal to minus 23, and a being the same as the a in this form, and you'll get the completed square form directly, right? This is one of the quickest way of finding the completed square forms of any quadratic function. We'll do more examples of this today as well. Sometimes they do not give you this standard form in the question. They will give you some other letters, or the signs might be different. For example, in place of negative inside the bracket, they might have positive in the standard form. It does not really matter. The letters could be different. What you would do would be, you would remember this form a into x minus h whole squared plus k. And once you remember that form, all you have to do is find the value of h and k in minus b over 2a formula. Once you have those two values, just input them in this standard form and you will get that completed square form. It doesn't matter if they have plus in the form that they gave and you have minus. It does not make any difference. The plus minus can be different, and that is perfectly okay. All right, so this is what we discussed in the last session. Now today, I want to start with discussing another possible method for finding the completed square form. So there's another way to do that as well. And I would want to start with that today. First of all, how to find the completed square form using another method. Okay, that's what I want to start with. And then we will also discuss how to solve equations after you have completed the square for a function like this. Okay. Now, first of all, let's start with another method for completing the square. So this question that we did in the last session, let's use the same example on same example to understand another method for completing the square. Okay. And then you can choose whichever of the two you prefer. You can use any of them to complete the square. In some cases, the second method becomes a bit complicated. For that reason, I recommend that you know this first method that we discussed here as well. Okay. Now let's discuss another method for completing the square. Completing the square. Now this is what you mostly learn when you study completing the square the first time. Let me go through this process as well. So you have this function 2x squared minus 8x minus 15. This is an expression that we've got. And what you want to do is you want to write this in the form a into x minus h whole squared plus k. All right. Now, how does this process work? How are we going to start? The first thing we do is we take whatever is the coefficient of x squared common outside. Okay, so whatever is the coefficient of x squared, the very first thing that we have to do is we have to take that common outside. Okay, let me write that down here. Take the coefficient of x squared common from the first two terms. Now, there are different variations of this. Some people take it common from all the three terms. You can do it using just the first two terms as well, keeping this constant outside as it is. It does not really matter. Both ways are okay. So if I take the coefficient of x squared common here, what am I going to be left with? So I have 2x squared minus 8x minus 15. Let's take 2 common outside. What does that leave us with inside? That leaves us with x squared minus 4x. Okay. And now what you're going to do is you're going to leave some space after this. Okay. And then write minus 15 outside. So take the coefficient of x squared common from the first two terms. And then this is the form that you end up getting. And now the next thing that you have to do is divide the coefficient of x. Divide the coefficient of x by 2. Then square it. Divide the coefficient of x by 2. Then you square it. Now, what's the coefficient of x? It's minus 4, technically. But since we're going to square it anyway, what we do is we ignore the negative sign generally, and we just focus on the number here. So divide 4 by 2. What do you get? You get 2 from that. And then you basically square this number. So once you've done this, you square this number. This is what you have until this point. Okay. Then what you have to do is you both add and subtract the result inside the brackets. Then you both add and subtract the result inside the brackets. Now, what does that mean? Once you have this form and you've taken 2 common outside, inside you have x squared minus 4x. What you've done is you've divided 4 by 2, that gives you 2. You've squared it, that gives you 2 squared. Then you both add and subtract this number, 2 squared, but then you subtract as well minus 2 squared inside the bracket. Outside you have minus 15 as it is. Now, how does that make sense? Why are we doing this? We are doing this because the first 3 terms, when we do this, become a perfect square. So the idea is, so you might be thinking, okay, we're doing plus 2 squared and then minus 2 squared. That just cancels everything out, right? That's why we're doing minus 2 squared in the first place, that if you're adding something, we have to balance that by subtracting something as well, right? But then why are we doing this in the first place? Because doing this converts these three terms into this form that you've seen before, a squared minus 2ab plus b squared. Once you follow these steps, what happens is these three terms turn out to be in this form, a squared minus 2ab plus b squared. That's for this particular example. For other examples, it might be a squared plus 2ab plus b squared form. So one of these two forms is what you're going to get here. And then what you can do is you can write them in completed square form, because what is a squared minus 2ab plus b squared? That is a minus b whole squared. And what is a squared plus 2ab plus b squared? That is a plus b whole squared. So you basically convert it to one of these two forms. It either becomes this or becomes this. Okay, once you follow this process. So now, in place of a, you have x, right? In place of b, you have 2. So in the next step, what you can do now is you can say these three terms can now be written as a minus b. So that means x. So this is a. And then you have this sign. You see this corresponds to this sign here on the right side. It corresponds to this sign. So basically, what eventually would happen would be, once you have this form, from the first term, you're just going to take this x value. The x comes down here like this. From the second term, you're going to take the negative sign. So this negative sign comes down here. And from the third term, you're going to take this number, which is 2. So it becomes x minus 2 whole squared. And now inside the brackets, you have a perfect square like this. It's x minus 2 whole squared. And then this is negative 4. This remains outside as it is. You have to simplify this. That's minus 4. And outside the brackets, you've got minus 15. And now you simplify everything. Inside, you have x minus 2 whole squared minus 4, right? So this number 2 outside, you can just multiply that inside the bracket now. And that becomes 2 into x minus 2 whole squared, 2 into minus 4, that is minus 8, minus 15. And that simplifies to 2 into x minus 2 whole squared minus 23. This is your completed square form. Okay. So how do you complete the square? Whatever is the coefficient of x squared, you take that common outside. Once you've done that, inside the bracket now, look at the coefficient of x, ignoring the sign, divide that by 2, square that number, and then both add and subtract that number inside the brackets. Once you do that, these three terms are going to give you a perfect square. And then you just simplify everything and you get that completed square form. This is exactly the same form that we got using the other method earlier as well. We got 2 into x minus 2 whole squared minus 23, right? This is another way of approaching that same problem using the second method now. Okay, makes sense? Let's do a couple of more examples on this now, because it is a bit complicated the first time you do it. It's a bit confusing. But once you get the hang of it and have done some practice questions, it should not be that complicated, because it's pretty standard. You get the same thing again and again. It keeps getting repeated. So it should not be that difficult. Let's do a few more examples. Let's say you have another function now. Okay, so let's say they want you to write down 4x squared minus 24x plus 37. in the form a into x plus b whole squared plus c. Okay, now this is what you want to do. Again, you want to complete the square for this. How is this going to work? What's the first step? You take the coefficient of x squared common outside. Let's start with that. Take the coefficient of x squared common. What does that leave you with inside? X squared minus 24 over 4, which is 6. X squared minus 6x. Leave some space, and outside the bracket, you've got the constant as it is. Okay. All right. Now, what do you do next? Whatever is the coefficient of x, you divide that by 2. That becomes 3. You square that and both add and subtract that number inside the brackets. Once you have done that, these first 3 terms are going to give you a perfect square because this is the form a squared minus 2ab plus b squared. So this can now be written as a minus b whole squared. From the first term, you get x. From the second term, you have this negative sign. And this b from the third term, which is 3x minus 3 whole squared minus 9 outside plus 37. Now you just multiply 4 inside, so it becomes 4 into x minus 3 whole squared minus 36 plus 37. And the result turns out to be 4 into x minus 3 whole squared plus 1. And that's your final result. That's what we were looking for. This is the completed square form for that function. Okay. Let's take another example. Let's say you had something else now, and now let's do something a bit more complicated that involves fractions. So let's say you have 3x squared plus 8x minus 15. Now you've got this function, and again, you want to convert it to a form like this. This is completed square form. Now, how do we start with this? Sometimes this process becomes a bit more complicated. When you take something common and inside the bracket, you end up getting a fraction. And that is what is going to happen in this case. This is the function that we have, right? 3x squared plus 8x minus 15. How do we start? What's the first thing we do? We take the coefficient of x squared common outside. So that leaves us with x squared plus. When we take 3 common out of 8, what does that leave us with? That is going to leave us with 8 over 3 times x. Okay, now let me just explain how that works. So for instance, when you take something common from this expression, let's say 4x squared plus 12x. If you take 4x common, for instance, what are you left with inside? You're left with x plus 3, right? Now, why do you have x plus 3 there? X plus 3 is because when you take 4x common, inside the brackets, you're basically thinking of this in your head, that 4x squared is divided by 4x. And that simplifies to x. And similarly, 12x is divided by 4x, and that simplifies to 3. So whatever you take common outside, that is essentially being divided by inside the brackets. That's the expression that you have to divide by inside the brackets. And that's what we're doing here. When we take 3 common outside, from the first term, we have 3x squared. When we take 3 common, we divide it by 3, and that gives us x squared. Now from 8, when you take 3 common, you're not left with an integer. Okay, so when you divide 8 by 3, it remains 8 over 3. So you write it like this. This is 8x over 3. All right, now leave some space, and outside you have minus 15 as it is. Okay. Now, once we have taken 3 common outside, again, we have to look at the coefficient of x. What's the coefficient of x? It's 8 over 3. Divide that number by 2. 8 over 3 divided by 2, what would that be? You can think of it like this. 8 over 3 divided by 2. That becomes 8 over 3 multiplied by 1 over 2. Right? So that's 4 over 3. 8 over 6 or 4 over 3. That's the half of 8 over 3. So it becomes 4 over 3 whole squared. You add this number, and then you subtract that same number minus 4 over 3 whole squared inside the brackets. Now, the first three terms, what do they give you? The first three terms give you a perfect square, x plus 4 over 3, right? So you have 3 into x plus 4 over 3 whole squared. Now this number, this is 16 over 9 minus 15 outside the brackets. Okay, now let's simplify this further. Multiply 3 inside, and that will give you 3 into x plus 4 over 3 whole squared minus 16 over 9 times 3. That will leave you with minus 16 over 3 minus 15. And now you have to simplify the number that is outside the brackets. Now, if it's a non-calculator paper, you can take LCM of this and see what that gives you. If it's in the calculator paper, what you would do would be just put this on your calculator, minus 16 divided by 3 minus 15, and your calculator will do it for you directly, and you get minus 61 over 3. This is the completed square form that you get. All right. Now, in this case, when you have fractions, I generally prefer using the earlier method because that makes things much easier, especially in these types of problems when you have to take something common outside and inside you're left with a fraction like this. In this case, the other method might be easier because you don't have to think as much in the other method. Let me do it using that as well. 3x squared plus 8x minus 15, right? This is the function. You want to complete the square for this. Now, for this, you need to remember this. For using this method, you need to remember the standard completed square form. Now, one form of quadratic functions is ax squared plus bx plus c. This is what most of you already are familiar with. But then this is the completed square form, a into x minus h whole squared plus k. All right, so this is what you want to convert it to. You have to remember this form. Now, in this form, a is the same as this a. So a is going to be the same. What's a? A is 3. Okay, so we can already have 3 here outside. Inside now, we need to figure out what the values of h and k are. How do you find them? H and k are the coordinates of the turning point. So you find the turning point. How can you find the turning point? Minus b over 2a. That should work, right? X equals minus b over 2 times a. Now, what is b? B is 8. So it becomes minus 8 over 2 times 3. And that gives you minus 4 over 3. This is the value of h. Okay. And then you put this number back in this expression, you'll get the corresponding y value as well. 3 into minus 4 over 3 whole squared plus 8 into minus 4 over 3 minus 15. You can put this in your calculator directly. You'll get the corresponding y value from this. 3 into minus 4 divided by 3 whole squared plus 8 times minus 4 divided by 3 minus 15. And what do we get from this? Minus 61 over 3. That's the value of k. You have h and k now. H is minus 4 over 3, right? And k is minus 61 over 3. Just input these values there in place of h and k, and you'll get your completed square form. 3 into x minus h. Now, minus 4 over 3, that becomes plus 4 over 3, x plus 4 over 3 whole squared. And outside, k is minus 61 over 3, so you have minus 61 over 3 outside. This is another way of finding that completed square form using this other method, minus b over 2a method. All right, I hope that makes sense. That was another example in this. Any questions on this? Any problems? No? Okay. Now, sometimes you don't have any coefficient of x squared outside. So for instance, you might have a form like this. That they have x squared minus 6x plus 15. What if you have a function like this, an expression like this? Now there's no coefficient of x squared. That actually makes things simpler because now you don't have to take anything common outside. Okay, you can just do it directly. X squared minus 6x, leave some space, you have plus 15 outside. Using the plus minus method, you have plus 3 squared because you divide 6 by 2, that gives you 3. You add 3 squared and also subtract 3 squared. The first 3 terms give you a perfect square, a minus b whole squared, right? So that becomes x minus 3 whole squared. Outside you have minus 9 plus 15, and that gives you x minus 3 whole squared plus 6. And this is your completed square form. Okay. All right. Now, this is how the completing square process works. Now, sometimes what they do is they ask you to solve a quadratic equation after making you do something like this in the first part of the question. So it might be like this, that the first part of the question is this, right? This is the first part of the question. And then in the second part, they ask you to solve a quadratic equation. So they might say, hence solve x squared minus 6x plus 15 equal to 0. Hence solve this equation. Now, when they use the word hence, that basically means that you have to use the previous part somehow. Now, there could be other ways of doing this. You could do this using quadratic formula, right? But since they've used the word hence here, that means you should use the previous part. Now, what have you done in the previous part? In the previous part, you have written this equation down, this function down in the completed square form like this. So what you can do is you can use that completed square form to solve this equation without using the quadratic formula. And in this case, they might ask you to give your answer in a form like this, for instance. So they might say, give your answer. Giving your answers in third form. Okay. Now they might do something like this. Now, in this question, actually, we would not be able to solve this because we would end up getting a negative inside the square root. But let me use a different example for this. Let's say we had a negative 15 outside. So instead of this plus 15, let's say we had a negative 15, and then do it using that example. If you had negative 15 outside, we would end up getting something like this. Okay, now I've slightly changed that example. And let's say this is the equation that we had, and we had to solve this equation, x squared minus 6x minus 15. Why did I change this? Because actually the first equation that I wrote, I just realized that we would not be able to solve that because you would end up getting a negative inside the square root. Okay, so I just wrote that equation randomly, and it turns out it's not actually solvable. But now this is something that we should be able to solve. Now, they want you to solve this equation and give your answer in third form. What is third form? Third form is the square root form. Okay, so you might have your answers in terms of square roots. That's what you want to write them down. Now, what would you do for this? Since you've already converted the left-hand side to the third form, you can write this equation like this. You can say this is x minus 3 whole squared minus 24 equal to 0. That this is what the equation is. Okay. And now you're not going to expand it, because if you were to expand it, and write it like this: x squared minus 6x plus 9 minus 24 equal to 0, x squared minus 6x minus 15 equal to 0, you'll get that same equation back. You don't want to expand it because the completed square form can actually help you find the solution much quicker directly. You can just take 24 to the other side so that it becomes x minus 3 whole squared equal to 24. Okay. And now you want the values of x, right? So you want to make x the subject. You want to get rid of the square for that. How do you get rid of the square? You take square root on both sides. Now, when you do that, it becomes x minus 3. The square root gets cancelled on the left side. The square gets cancelled on the left side. On the right side, when you take square root of 24, what does that give you? Remember, you have to give your answers in third form. Do not use decimals. Just write it like this, square root of 24. But remember, whenever we take square root of in an equation ourselves, we always have to put plus minus there. Okay, whenever we're taking square root ourselves, we have to put plus minus there because both possibilities can be there. Now, this is the equation. You can split it into two parts now. X minus 3 equals plus square root of 24 and x minus 3 equals minus square root of 24. 3 goes to the other side and that gives you 3 plus square root of 24. And in this case, it gives you 3 minus square root of 24. These are the two solutions that we get from this. Now, sometimes they might want you to simplify the third as well, which we will learn later, as I said in one of the earlier classes as well, how to simplify third forms. This can actually be simplified like this. I'll quickly do it for you right now, but we'll discuss it in a bit more detail in one of our other classes later on. Square root of 24, what you do is you think of all the perfect square that you know. 1, 4, 9, 16, 25, and so on. What's the largest number that you see here that's a factor of 24? If there is any. In this case, 4 is a factor, right? So out of these squares, 4 is the largest number that we have that's a factor of 24. And what we can do with this is we can write 24 as 4 times 6 inside the square root. Now, 4 is 2 squared, so we can say that's 2 squared times 6. And now for 2, the square and square root will get cancelled, and we can write that outside so that it becomes 3 plus 2 times square root of 6. This is one value of x. Then the other one is going to become 3 minus 2 times square root of 6. Okay, and these are your final answers: 3 plus 2 under root 6 and 3 minus 2 under root 6. That is what we wanted at the end. All right, so this is something that you also need to be able to do. In the first part, they might ask you to complete the square of a function, and then in the next part, you can use that first part to solve that equation. Take the constant to the other side, take square root on both sides. Remember to put plus minus when you take the square root, and then you can find the values of x in third form like this. Okay. Let me do another example on this quickly. We could use this earlier form as well. That will make it slightly more complicated. So it might be that in the first part of a question, they ask you to write this down in completed square form, right? This is part A. And then in the next part, they might you to solve that equation. So they might say, hence solve 3x squared plus 8x minus 15 equal to 0. Again, giving your answers in third form. Giving your answers in third form. Okay. Now, again, in the first part, we've already solved this equation. Completed the square for the left side. All you have to do is use that form and see what that gives you when you make x the subject. So what's the completed square form for this? Okay, so this was 3 into x plus 4 over 3 whole squared here. So that gives us 3 into x plus 4 over 3 whole squared minus 61 over 3 equal to 0. We can write the left-hand side like this. Okay. And now what we've got to do is, we have to make x the subject. Now, how is that going to work? You take 61 over 3 to the right side. So it becomes 3 into x plus 4 over 3 whole squared equal to 61 over 3. Okay, now you have to make x the subject, remember. You divide 3 on the other side. X plus 4 over 3 whole squared equals 61 over 9 when you divide 3 on the other side. Okay. Now, since you want to get rid of the square here, you can take square root on both sides. When you take square root on both sides, it becomes x plus 4 over 3 equal to square root of 61 over 9. But remember, when you take square root, you have to have plus minus there. So now it becomes x plus 4 over 3 equal to square root of 61 over 9. That is one possibility. Or x plus 4 over 3 minus square root of 61 over 9. In fact, yeah, so equal to 61, square root of 61 over 9. Now, what's the value of x that we get from this? Take 4 over 3 to the other side. So it becomes minus 4 over 3 plus square root of 61 over 9. Or x equals minus 4 over 3. There was supposed to be a minus here on the other side. Minus square root of 61 over 9. These are the two values of x that you get from this. You could try to simplify this further a bit because 9 square root is 3. You could write that outside if you wanted. So you can say this is minus 4 over 3 plus square root of 61 over 3. And then you could take LCM as well. Again, if you wanted, it's not necessary. You could leave it in the previous form as well because that's a valid third form, or you could simplify it like this, minus square root of 61 with the denominator being outside the square root because square root of 9 is 3. These are the two values of x that you get as the solutions to that equation in third form. If you wanted to write this in decimals, you could put this on your calculator and you get the decimal value. Otherwise, you leave your answers like this. Okay. All right, so I hope that makes sense. This is how you solve equations using completed square form as well. And also this is the other method. Now remember, both of these methods, you can use whichever of them you prefer. One is using the minus b over 2a formula. You find the turning point first of all, put that in this standard form, a into x minus h whole square plus k. The other is this more common method where you take the coefficient of x square common outside, divide the coefficient of x by 2, then square it, add and subtract it inside the brackets. Then you get one of these two forms, a square minus 2ab plus b squared, or a square plus 2ab plus b squared. You write it in that form, simplify everything, and you get your completed square form for that. Okay. Now, another thing, when you have a completed square form, you should be able to write down the turning point of the quadratic function from that form as well. Now, what do I mean by that? Remember what we said, if we have a standard form like this for completed square form, a into x minus h whole squared plus k, in this standard form, what's the turning point? The turning point is h and k. That's the turning point. Okay. So given a function in this form already, so sometimes this can happen as well, that you have a function already in this form, and you have to figure out the turning point of that function for for turning point of that function for doing something that they've asked about. How would you do that? Let's say you've got something like this: minus 3 into x plus 2 whole squared plus 7. Or let's use a slightly simpler form first of all. For the first example, minus 3 into x minus 2 whole squared plus 7. Now, what's the turning point of this function? You compare it with the standard form and see what that gives you. When you compare with the standard form, in place of minus h, you have minus 2. And in place of plus k, you have plus 7. So what's the value of h and what's the value of k? You can think of it like this: minus h equals minus 2, h equals 2. So the x coordinate of the turning point is 2. Plus k equals plus 7, and the value of k is 7, so the y coordinate is plus 7. This is the turning point of this function 2 and 7. Okay. Now notice we have a negative sign with h here. Because of that, what happens is, whatever is the number that you have here, since this minus has to be removed from the equation, this number will actually change its sign when we write down its coordinate, right? So if we have minus 2 inside, the turning point is going to be 2. The x coordinate of the turning point is going to be 2. If we have plus 7 here, the y coordinate is going to be the same sign because this is plus k. Since h has a negative sign with it, when you write down the x coordinate using this number, the sign of that number is going to change. If the number inside is negative, the x coordinate is going to be positive. For k, the number remains the same. Now, if you keep this in mind, you can actually write down the turning point directly for any function in this form. So if you have 4 into x minus 5 whole squared plus 3, what's the turning point of this? The x coordinate is going to be this number with the sign flipped. Flip this sign. This is minus 5. This becomes plus 5. The number outside remains the same. That's 3. 5, 3 is the turning point. If you had minus 7 into x plus 1 whole squared minus 7, what about this now? The number inside this sign is going to be flipped. So this becomes minus 1. The number outside this sign is going to remain the same. That is negative 7. If you had 5 over 3 into x plus 2 over 3 whole squared minus, or let's say plus 3 outside, what happens to this now? The number inside, this changes its sign, so it becomes minus 2 over 3. The x coordinate of the turning point will be minus 2 over 3. The number outside, this sign is going to remain the same, and the y coordinate is just 3. So given a completed square form, this is how you can write down the turning point from that. Okay, and now how do we know if the turning point is a maximum point or a minimum point? That is going to be determined by this number outside a. Remember the shapes of the quadratic functions. If it's a U-shaped curve, the coefficient of x squared is positive. If it's an N-shaped curve, the coefficient of x squared is negative. So this number a is what decides which of these two forms it is going to be. So if you have a negative sign outside, what does that mean? It's a shape like this, right? That means this is a maximum point. In the second case, the number outside is positive. This is going to be a U-shaped function. That means the turning point in this case is going to be a minimum point. In the third case, again, it's a maximum because it's an N-shape. Because of that negative number, this is a maximum point. And in the last case, it's a U-shaped again because this number is positive. This is going to be a minimum point. Okay, so the process for finding the turning point is the same. However, whether that turning point is a maximum or a minimum is decided by these numbers outside. If the number outside is positive, it's a U-shaped function. If the number outside is negative, it's an N-shaped function. Okay. Is that all right? Any problems with this? Okay, good. Now, the next thing that you need to be able to do is solve simultaneous equations. Let's talk about that, how to solve simultaneous equations. In fact, before that, since using that, since for solving equations, you also need to be able to make variables subject. Let's start with that first of all. Making a variable the subject of an equation making a particular variable subject of an equation. Okay, so you get this 2-3 mark question in the exam often as well, where you have some equation given and you have to make one variable given in the equation the subject of that equation. Okay, now let's understand how you can do this. Let's do this using an example. Let's say we've got something like this. Two xy, or let's start with something simpler. First of all, you have y equal to -2 plus 7x whole divided by 5. What you want to do is you want to make x the subject of this equation. Okay. Now, the idea is you want to isolate this x, take it to one side of the equation and everything else to the other side of the equation. Okay. You want to bring this x to take this x to one side, everything else to the other side of the equation. Now, how is that going to work? You can take 5. First of all, you can simplify this by getting rid of the fraction in this case. You've got 5 here, multiply that on the left side. What does that give you? That gives you 5y. On the right side, you have -2 plus 7x. Remember, you want to make this x the subject. Now, this term is already positive in this case, right? Since you want to make x the subject, remember you can't have minus x. It should be x equal to something, not minus x equal to something. Now, since x is already positive here on the right side, what we can do is we can keep it on the right side as it is. Take 2 to the other side, so it becomes 5y plus 2 equal to 7x. And now divide by 7 to get rid of the 7 from this as well. And that leaves you with 5y plus 2 divided by 7. That equals x. And that's what you wanted to do. Now, you can write it like this if you want. Generally, we write the subject on the left side of the equation. It's not necessary though, but it's a convention that we tend to write the subject of an equation on the left side. So at the end, this is what you can do. You can take x to the other side. All right, let's take another example. Let's say you've got something like this now, a function like this, s equals n over 2 into a plus b. Okay, and what you want to do is you want to make b the subject. This is the equation. Make b the subject of this equation. Now, how is this going to work? You multiply 2 to the other side. Remember, this is the b that we want to isolate, right? So get rid of everything else. Get rid of everything else from this equation. Okay, I'm sorry about it. Let's put it on silent. Okay. Take 2 to the other side first of all to get rid of the fraction. So it becomes 2s equals n into a plus b. All right. Then this is n multiplying. One way to do this could be that you first multiply n inside, but it's going to be easier if you don't do that because b is already kind of isolated here because there's nothing multiplying, right? So it will be easier to just divide by n on the other side first of all. Just divide n on the other side. Don't multiply on the right side because it'll make things longer. You can just divide n on the other side. So it becomes 2s over n equals a plus b. Okay, one last step now. Take a to the other side, and that gives you 2s over n minus a equal to b. And that's b the subject, 2s over n minus a. All right, so this is something that you have to do sometimes. Make one variable the subject like this. Now, these were simpler examples. Sometimes you have square roots involved. What do you do in those cases? For instance, if you have something like this, c equals square root of 8a minus 3b. Let's say we have something like this. And now, again, what we want to do is we want to make b the subject. Now, when we want to make b the subject, what that means is b should not have any power and nothing should be multiplying with it, right? B should be completely isolated. It should be b power 1, right? So there should be no power on it, essentially. Right now, we have a square root here. How do you get rid of the square root? You can square both sides. When you square both sides, on the left side, you get c squared. On the right side, you have 8a minus 3b. And now you have to isolate this b, remember. Now, it's negative right now. Since you want it to be positive as well, it's a good idea to take it to the left side. So that gives you 3b equal to 8a minus c squared. And now divide by 3, and that gives you 8a minus c squared divided by 3. This is b as the subject. Okay. Now, here we had constants. Mostly, let me think of a more difficult example where you have multiple x terms. So in the examples that we did until now, the subject that we wanted, the variable that we wanted to make the subject, there was only one appearance of that. For example, in this, there was only one b here, and here as well, there was only one b, and here we only had one x. Now, sometimes you can have multiple terms of the variable that you want to make subject as well. Let's do something a bit more complicated. So for instance, what if you had something like this? 4 equal to square root of cx plus 1 divided by dx minus 1. And now what you want to do is you want to make x the subject. Okay. Sometimes they can change the wording of this question as well and say, find x in terms of c and d. That means the same thing essentially, right? Let me use that wording here. So for instance, they might say, find x in terms of which variables are there, which constants are there, c and d. So find x in terms of c and d. That's another way of writing this, of asking the same thing basically. They want you to make x the subject. Okay, when you have x the subject, that will be x in terms of c and d. All right. Now, what do we do now? 4 equals square root of cx plus 1 divided by dx minus 1. You want to make x the subject, remember? Square both sides and see what that gives you. Why do you want to square the side? Because there's a square root right now. We want to get rid of that. For that, we just square both sides like this, right? When we do that on the left side, we would get 16. On the right side, we have cx plus 1 divided by dx minus 1. Okay, remember, we want to make x the subject. Okay. All right, so we have this x here, we have this x here. We want x terms on one side, everything else on the other side. But before we can do that, let's get rid of this fraction. First of all, multiply this denominator on the left side. What do we get? 16 times this. That would be 16 dx minus 16 equal to cx plus 1. Okay, this is what the equation becomes when you multiply this on the left side. We want to make x the subject. For that, what we do is we take all x terms to one side, everything else to the other side. So in this case, we have two x terms. We have this x term, we have this x term. We take cx to the left side as well. So it becomes 16 dx minus cx. And take this 16 to the other side. That becomes 1 plus 16, and that is 17. X needs to be the subject. What do we do for that now? We have x here, we have x here. When we have multiple terms of the variable that we want to make the subject, we take all of those terms to one side, first of all, and then take the variable common. So in this case, we want to make x the subject. We take x common from the left side, and that leaves us with 16b minus c equal to 17. And now we can divide 16 minus 17, 17 on the other side, and that is 17 over 16b minus c. That is x made the subject of this equation. And we have x in terms of d and c here. Okay, so you should be able to make a variable the subject of an equation like this. All right, now that you understand how to make a variable the subject, let's quickly understand how to solve simultaneous equations. Okay, that's the next thing that we quickly want to understand before we end. And what I'll do for that is I will leave an example in front of you here. And I actually need a short break right now as well. So I'll leave an example. I'll let you try this first, and then we'll discuss it. And I'll be back in 4-5 minutes. I'll take a short break. We'll end our class in about 15 minutes from now. Okay, so we'll spend about 10 minutes on understanding how to solve simultaneous equations. Solving simultaneous equations. Okay, I'm leaving you with an example right now, and then we will discuss how to do it together. Let's say you have a set of equations like this: 3x plus 4y equal to 1. This is one equation. And there's another equation, 5x minus 8y equal to 9. What we want to do is we want to solve these two equations simultaneously. Okay, I'll give you a couple of minutes. Try to solve this equation. Let me know in the chat box the solutions to this set of equations, and then we'll quickly discuss multiple ways of solving these two equations. Okay, I need to be somewhere for a few minutes. I'll be back. Okay, just 4-5 minutes, and I'll get back after that. Please let me know the solutions of this in the chat box quickly. Okay, so let's check if the answers that you're getting are correct or not. So these are two simultaneous equations that we want to solve. Okay, 3x plus 4y equals 1 and 5x minus 8y equals 9. Now, how do we solve simultaneous equations? We've got multiple methods for solving simultaneous equations. Number one, we can do it using a process that we call elimination. Let's start with that process, elimination, and see how this works. Now, the idea of elimination is that we want to write these equations down in such a way that we can eliminate one of the two variables, that means either x or y, by adding or subtracting these equations. Now, let's see how this would work. So basically, this is what we think of in our head. Can we multiply one of these two equations with some number so that the coefficients of x become the same in both of them, or the coefficients of y become the same in both of them. Plus minus does not make any difference, but the numbers should be the same. Okay, for example, if we have 8 here, we can have 8 here somehow, no matter if it's plus or minus, that doesn't matter. If we have 3 and 5, we could multiply the equations with some numbers in such a way that we have the same coefficients of x in both equations. And then we could either add or subtract the equations to eliminate one of the variable. In this case, for instance, if I were to multiply the first equation by 2, so you see the coefficient of y in the second equation is 8, right? Ignoring the sign, the number is 8, right? This is 4. If I multiply 4 by 2, that will give me 8. So what I can do is I can multiply the first equation by 2. Now, when we do that, the first equation can be written like this: 6x plus 8y equal to 2. And the second equation is 5x minus 8y equal to 9. And now, since the coefficients of y are the same, the numerical values are the same. If I were to add these two equations, add equation 1 and equation 2, when the x terms get added, they give me 11 times x. When the y terms get added, 8y and minus 8y, they get eliminated. The y terms get eliminated, and we're left with only 11 on the other side. 11x equals 11. 11 over 11 gives us 1. That's the value of x that we were looking for. Once we've got the value of x, what we do is we put this value of x back in any of these two equations. It doesn't matter. You can put this here, you can put this here, and you'll get the corresponding value of y from that. For instance, I could put this value back in, let's say, 5x minus 8y equals 9. And that would give me 5 into 1 minus 8y equal to 9. And 8y equals 5 minus 9, which is minus 4. And y equals minus 4 over 8, which is minus 1 over 2. Or we can say minus 0.5. So the values of x and y, the solutions of this set of equations is x equals 1 and y equals minus 0.5 using elimination. Okay, this is one way to solve these equations using elimination. Now, in this case, we added the two equations, right? Because this was plus 8y, this was minus 8y. When we added the equations, the y terms got cancelled. Another way to do elimination in this same problem could be that we could make the coefficients of x the same. How would that work in this example? If I were to make the coefficients of x the same, what's the LCM of 3 and 5? The lowest common multiple of 3 and 5, that is 15. So that is a number that I can try to achieve by multiplying the first equation by some number. What can I multiply 3 by to get 15? I can multiply 3 by 5, and that will give me 15 in the first equation. So I get 15x plus 20y equal to 5. And in the second equation, I can multiply by 3, because when I multiply this by 3, the coefficient of x here will also be 15. So that becomes 15x minus 8 times 3 is 24 equals 9 times 3, which is 27. Now in this case, the coefficients of x become the same. If I want to cancel these two, I would have to subtract the second equation from the first equation. So I subtract the second equation. Now, this will get cancelled. An easy way to do this is when you want to subtract, you change the signs of the second equation. So this becomes minus, this becomes plus, this becomes minus. You cancel these two out. 20 plus 24, that is 48y equal to 5 minus 27, that's minus 22. Sorry, this was 44y on the left side. And then y equals minus 22 over 44, which is minus 0.5. You put this value of y back in any one of those two equations, and you'll get the corresponding value for x. So if I were to put this back in 5x minus 8y equals 9 again, that would give me 5x minus 8 into minus 0.5 equal to 9. And from that, I can find the value of x as well. It becomes 5x plus 4 equal to 9, 5x equal to 5, and x equal to 1. Again, we got the same two values, y equals minus 0.5 and x equals 1. So we can both add and subtract equations, and we can eliminate any of the two variables, right? We can eliminate x, we can eliminate y, but depending on the set of equations that we're given, doing one will be easier than the other. So for example, in this case, it was much easier to make the coefficients of y the same, because for that, you just had to multiply the first equation by 2, and that's it. Elimination of y was much easier in this case. Eliminating x was more complicated because in that case, we had to change both equations. So generally, you do elimination when multiplying one equation by something will help you eliminate one of the variables. When you have to change both equations somehow, then it becomes a bit more complicated. And in cases like this, when you can only do something like this, the other method, substitution, might be a bit more suitable. But this is how elimination would work. You can either make the coefficients of x the same or y the same, and then you either add the equations or subtract the equations to eliminate one of the variables. In the first method, in the first example that we did, we eliminated y. In the second case, we eliminated x. Both of them give us the same results at the end. Okay, that's one way to solve simultaneous equations. Now, if I would take the same set of equations and solve them using substitution, let's see how that process would work. Substitution. Now, how does substitution work? The idea of substitution is that we make one variable the subject in one equation, and we substitute that expression in the second equation. So for example, in this case, if from the first equation I make y the subject, what does that give me? 4y equals 1 minus 3x divided by 4 on the other side, and that will be 1 minus 3x whole divided by 4. And now put this in the other equation. So you put y equal to 1 minus 3x over 4 in this other equation. So the idea is make one variable the subject from one equation, put that in the other equation. Generally, you would make such a variable the subject that does not have any coefficient. In this case, both x and y have coefficients in both equations. Sometimes you end up getting equations like this. For instance, you have x plus 2y equal to 9, and you have, let's say, 3x minus 5y equal to 10. Now, look at all of these coefficients. Which one of them is 1? The coefficient of x is 1. Making x the subject and putting that in the other equation is going to make things simpler. Why? Because if there's no coefficient of x outside, you would not get a fraction here. In this case, when we made y the subject, we got a fraction because we had to divide by 4, and that makes things a bit more complicated. That makes the calculation a bit more complicated. In this case, we did not have a choice because all of them have some number outside, which is not 1. So we would end up getting a fraction in any case. But in case we can avoid that, for example, in cases like these where at least one variable has a coefficient of 1, I would recommend that you make that the subject and put that in the other equation. For example, in this case, a good idea would be to make x the subject because that avoids fractions, and put that in the other equation. Okay, now that's just a side point that I wanted to make there. But in this case, this example, you would just make y the subject, y equals 1 minus 3x divided by 4. Put that in the other equation in place of y, and this would become 5x minus 8 times 1 minus 3x divided by 4. On the other side, you've got 9. Now, 4 and 8, they get cancelled, and you have 2 left here. That becomes 5x minus 2 minus and minus, that becomes plus. So plus 3x equals 9. 8x equals, okay, there was 2 there as well. Minus 2 times minus 3x, that should have been plus 6x. So that actually becomes 11x equals 11 and x equals 1. Put that back in this equation now. You get the corresponding value of x as well, which is 1 minus 3, corresponding value of y as well, which is 1 minus 3 over 4. That's minus 2 over 4, which is minus 0.5. So the values of x and y therefore are 1 and minus 0.5 respectively. Okay, this is how the substitution process works. You make one variable the subject in one equation, put that in the other equation. You'll get the value of one variable, and then you can find the other one as well, like this. Okay, that's how substitution works. This is one way of doing substitution. There's another variation of substitution that's also called substitution, but there's another way of doing the same thing, and that works like this. So the same set of equations, just one last example quickly, then we end for today. Please make sure that you're attempting the worksheets that are uploaded. That's extremely important. In the next class, you can let me know any problems that you've had until now. We'll also discuss them before we start our next concept. Okay, so please make sure to complete the worksheets for factorization, for quadratics. I also upload one for simultaneous equations. All of these are fairly straightforward topics. In case there are any questions that you are not able to do, let me know in the next class and we would discuss that. Okay, now another way of doing substitution is like this. It's another variation of substitution. And the idea is we make one variable the subject in both equations. Okay, make one variable the subject in both equations. It could either be y, it could be x, it doesn't matter. Any variable, you have to make that the subject in both equations. So in the first equation, for instance, I can say this is 4y equals 1 minus 3x and y equals 1 minus 3x over 4. Make y the subject in the first equation. Make y the subject in the second equation as well. 5x minus 9 equals 8y. And then y equals 5x minus 9 divided by 8. Okay, so you've got y the subject in both equations. Now, once you have the same variable the subject in both equations, what you do is you equate them now, right? Y equals this and y equals this. That means 1 minus 3x over 4 should equal 5x minus 9 over 8. And from this, you can find the value of x. Now, this is also another variation of substitution as well, because essentially what we're doing is we're putting this value of y in this equation in place of this y, and that gives me this, right? But that's another way of looking at it, that you make the same variable the subject in both equations and then equate both of them like this. We will do this a lot when we solve simultaneous equations in A levels later on, because a lot of times you have one quadratic equation, one linear equation that you have to solve simultaneously. This is the idea that we use a lot later on. But you can do it here as well. Make the same variable the subject, and then put them equal to each other. Now you can cross multiply. That gives you 8 minus 24x and 20x minus 36. 44x equal to 44. And the value of x turns out to be 1. That's the value of x that we were looking for. Put that value of x back in any of those two functions. 1 minus 3 times 1 divided by 4. Y equals minus 0.5. And you get the values of x and y from this as well. Okay, so You can do elimination. That's one way of solving simultaneous equations. You can use substitution. There are two variations of substitution. You can either make one variable the subject from one equation, put that in the other equation, or you can make the same variable the subject in both equations and then equate them like this. Okay, so you can use whichever of these methods you prefer. They would generally not require you to use a particular method. You can use any method that you prefer. Okay, now before we end, let me just show you how to do this on your calculator. For the calculator paper, what you can also do is you can verify your answers on a calculator. Now you have to show complete working in your work. This is just going to be for verification. So for example, on this version, I can go to menu and then equation. The first option is simultaneous equations. I press 1. What's the number of unknowns? 2 unknowns, x and y. I press 2 for that. Write down the coefficients of the first equation. 3. Press the equal to button. 4, equal to button. On the other side, the constant is 1. The other equation, 5 minus 8 and 9. And that's it. Press the equal to button again. You get the value of x, which is 1. And you get the value of y, which is minus 1 over 2. You can confirm your answers in case the calculator is giving you different answers from what you have. That means you've done something wrong. You can check your working again and figure out your error and correct that. Okay, you can use this for verification. You should definitely have it in the exam. You should know how to do this in the exam on the calculator paper. Of course, if it's a non-calculator paper, once you've got the values of x and y, you can put them back in the equations to check if the equations are satisfied. If they are, then that would confirm that it's the correct solution as well. Okay, so that's it for today. I'll see you again in the next class. In the next class, we will most likely be starting coordinate geometry, inshallah. But I'll confirm that as well, but most likely it's going to be coordinate geometry. If you have any questions, you can let me know quickly. Otherwise, we end this here. No problems? All right, good. So that's it. I'll see you again in the next session. Then please make sure to attempt the worksheets and let me know if there are any problems in them. And I'll see you again in the next class. Allah Hafiz.